In this video, let's work through the quizzes I create for my classes. I make this recording, uses this app, so it should work pretty fine. So first of all, please don't forget to write down your name. I'll put here, this is my key. And then please write everything carefully, neatly, and put the answer in the box or a circle. This speeds up grading by quite a lot. So in this question, we are asked to look at the graph of the function and find the function's domain. The function domain is what are the possible inputs we can have for this function. So you're looking at the x-axis. See those arrows at the ends? That means the function is infinitely decreasing to the left and to the right. This means that all possible x can be used for this function, so all x are in the domain, all real numbers. You can do minus infinity to infinity using interval notation or the real numbers notation. The range of the function should be looked at the y-axis. What are the possible outputs for this function? Well, it seems like it's not going higher than y equals 0, but it goes to minus infinity. So it goes deeply down to the negative numbers on the height. So we can say it will be from minus infinity to 0. And it's possible to get 0, so I will include it using brackets notation. X-intercepts, that is where the function touches x-axis. So x-axis is over here, and I need to see what are the zeros of the functions. Those are x-intercepts. Sometimes they're called zeros. Or the solutions. I can see 2 points at 0, 0 and at 2, 0. So these are my two intercepts. 0, 0, which will be also y-intercept because this is where the graph of the function touches a y-axis, and 2, 0. Y-intercept is where the function touches y-axis, and I only see 1 point, the origin, 0, 0. Now, let me continue here. For the E, we have two questions. What is f at minus 0.5? 0.5, that is my x-axis number. So that's my input. Let me find it on the x-axis. Minus 0.5, it's over here, minus 0.5. Now I need to look where the f of x is going to be. Not very clear, but seems like, let me see. Seems like it's either minus 2. No, seems like it's minus 1. I think that's the height. Yes, that is minus 1. Here it is. So at minus 0.5, we got height minus 1. So it's 1 unit below x-axis on the y-axis. For the f of 2, what we're going to have 2, again, that's your input, x. So what is my y? Seems like that's 0. So this is my output for f of 2, 0. Now for f, they want us to find open intervals in which the function is increasing. Now, the way I teach it, you put pencil on the graph of the function. If the pencil is increasing, this is where the graph of the function is increasing. See, it stopped increasing. And then over here, it's keep increasing more. So, what is going to be the answer for f? For f, it's increasing from minus infinity till that moment when I said it's stopped. It did not stop. It actually reached local maximum there. But it stopped at x equals 0. Remember, we're indicating x-axis here. Then, it was also increasing here from 1 to 2. Remember, we only use open intervals for these questions. Decreasing. This is where you put pencil. Let's use some kind of blue color. Put a pencil on the graph and it's going down. That's where the graph of the function is decreasing. So it's happening from 0 to 1 and from 2 to plus infinity. From 0 to 1 and then from 2 to plus infinity. That is G, decreasing. You see we covered all the domain, minus infinity to 0, 0 to 1, 1 to 2, 2 to plus infinity. So feels like we did good. Increasing. Last two questions are asking for maximum and minimum points. Local or relative maximum. Local relative maximum are where those hills are, the tops of the mountains. So we have 0, 0, and 2, 0. By coincidence, it's also X-intercept points. The minimum point is this guy over here. That's a local pit, if you want to see it this way. The coordinate for this is 1 and minus 1. It's only local minimum because actually points graph of the function has more lower points after and before that point. So it's a minimum only locally. And that's already a good problem being solved. That's how we discuss problem number 1 for our first quiz, where we learn how to figure out from the graph domain and range, x-intercepts, y-intercepts, how to work with the inputs and outputs of the function, where the function is increasing, decreasing, and has local extreme values.